Good morning, everyone. Myself Chaitanya, and in today's videos, we are discussing about the real world project. So it's nothing but self-driving car and its navigation and the collision avoidance. So basically, in this video, we are just discussing concepts and how the self-driving car works and everything, and how it's percept data with the sensor modules and everything, and how can we implement it purely based on the software. So everything we can only the topics and the concepts are being explained in this video. So if you need any code explanation or the code or everything, so do please visit next video. So let us dive into the topic. And first, I will show you the architecture of the modern application, how it works. So basically, for every application, it's basically divided into the four modules. And in a self-driving car, it's divided into the four modules, and the module one is nothing but the sensor ground, and the module three is perception ground, and the module three is planning. And at last, the action we need to be getting any action, and the car should take any action, right? So it's the control ground. In the perception ground, we'll use the hardware components to perceive data or to see data for the environment. For example, we are using the LiDAR for finding the distance between your car and the car which is autonomous to the opposite cars, and the cameras for traffic lights, signals, and everything, and the radar for detecting the speed and the large objects, everything, and how the weather will work, everything would be detected by the radar. And in the module 2, it's a perception ground. So the data of the module 1 is been taken to the module 2, and it perceives data or it understands the data. For example, it uses the models like YOLO, MiDaS, and semantic segmentation for the segmentation of the road and everything. And to pursue the information and to know what are the objects are being present in the in the environment, or what is the drivable area we can drive. And based on this module 2, it would take a plan to how it can overcome or how it can solve the problem, or how it can make action. So it's the basically module three, the planning ground. In the planning ground, it would be making a prediction and the route planning. Everything planning is being done in the module three. While we come to the module two, it's an action, the control ground. So the car takes an action, for example, the reducing speed or increasing speed, overtaking it, and the steer angle, throttle, and everything has been taken in the module 4. So this is the overall picture of the autonomous car, and I have divided into the four modules and explain you guys a single module so everyone can understand clearly. So for building an end-to-end application in any other companies also, they would be using the multiple architectures and the multiple frameworks to build an end-to-end application, which we are using today. For example, ChatGPT. ChatGPT is being using Ray for the distributing, clustering, and the model implementation, and many more NLP models and everything. So it's the total idea of the self-driving car and their architectures. So for implementing software, totally on the software based, we would be removing the module 2, and from the module 2, we are implementing the self-driving car. So you guys can ask a question: how can it predict the distance between the our vehicle or the autonomous vehicle to the opposite vehicle? So we are using a model called MiDaS for the depth estimation. So the depth estimation is nothing but it would be finding the distance between the autonomous vehicle to the front vehicle which is going. So basically, we are taking a real world video. So I will show you guys the video. So basically, I am taking input of this video and converting into the frames and applying each and every module to this video. So basically, everything is explained technically in the next video. So you guys please visit if you need any technical details. And so I will show you the architecture, what we are following to implement. And so I have divided a project into the three modules, and first one is the perception software, and the second one is planning software, and third one is the control software. In the perception software, I am implementing the YOLO and MiDaS and the DeepSORT. So in the place of the DeepSORT, I am applying byte track for the tagging of the objects. So input, I mean, we would be giving an input to the perception software, and we would be getting an output. It's also a frame. I am stacking each and every frame and making it as an output video. So basically the input video is been converted into the frames, and that frames again compressed into the video with the help of the codec and everything. So it's related technically. You can visit next video so you can totally understand the software and everything. So in the planning software, I would be using the semantic segmentation and the for the path planning. I am using the Yester algorithm to find the shortest path or to overtake an vehicle or everything. So semantic segmentation is nothing but it segments the road which is drivable with the green color, and the output of this module 2 is being passed to the control block or the control software module 3. So basically in the module 3, so I am with the help of the thresholds. So I am basically denoting or the describing the steer angle and the throttle and brake, whether the road is empty or whether we can overtake that vehicle with the help of the pixels. So I am denoting my vehicle length in terms of the pixels. So it calculates the differences of the above vehicle and our vehicle. So it with the help of that difference, we would be denoting whether we can overtake or everything is being done in the module 3. And in the module 1, the YOLO is used for the recognition of the objects. So especially we would be using YOLO version 8. It's speed and easy to use. And for the MiDaS depth estimation and the tracking. So the output of the module 1, I will show you in this video. So for the technical background and the technical details, you can visit next video. And this is the output using YOLO. So we would be getting the frames of each and every object. So it detecting the class, right? So in the code, we would be creating a list and passing the what are the classes, and it selects according to that. So you can see this, and at last we would be removing this frame person with the confidence interval of 0.76, because we are implementing the A-star algorithm, right? So we will do region of interest. So we will cut this and we will be seeing from mirror view. So it's the YOLO, and I will show you the depth estimation. So with the output of the distance estimation, you can see that it is predicting the class as well as the distance as 0.43 meters and each and every distance. So MiDaS is basically used for the depth estimation. And the module 1 output is being given by. So this is a module 1 output. You can see that ID of each and every unique ID of each and every car. So it is done by using the byte track. So you can use your own tracker, or there are multiple trackers, but byte track is easy to use. So it's an final video of the module 1. So while coming to the module 2, it's an planning software. We would be implementing the semantic segmentation and the Yester algorithm. For the semantic segmentation, we can easily segment the road. And after the segmentation, we need to be driving the path or the shortest path which we need to be going for overtaking the vehicle. So for that, we are planning to use the path planning algorithm. It's Yester algorithm. So I would be showing you the output of the second module. So basically send the output of the first module as an input to the second module. So the output of the module 1 plus 2, it's a module. You can see that segmentation over the road, it's a drivable area. So you can see that below the cars, it's black. So it's non-drivable area. And also you can see this. So it's totally describing the YOLO, MiDaS, and the byte track with the segmentation. So it's an output of the second module. So basically, I have chosen a real world example and converted into the frames. So you can choose your output, I mean input, and you can pass it. So in the module 3, it's an control module. So in this module, we need to be describing the how much speed should we go there with the help of the thresholds and everything. So we would be using the PID controllers and the steering, everything. So for the technical aspects, you can visit the next video. So I would be showing you the output of the final module 1, module 2, and module 3. So it's the final view. So I have changed the threshold. So that's why, so you can change, see the stop and the speed, everything. So you can change your threshold and you can see the values. Now you can see its drive on changing the values and of the speed, how much we can achieve in that road and everything. So it's basically our project, and I think you are understanding everything and every module falls and everything. So I would be showing you the architectures of each and every model. So it's an architecture of the YOLO. So we are compressing the video file, right? I mean, we are passing the compressed video file. For example, it's an extension MP4. It's already compressed video, so we cannot process it. So we need to be unprocess it, and process that frame, and we need to be do model implementation on that particular frame. So by using the CV2 library, we can extract the raw frame, then passing that into the YOLO and encoding and writing, and at last we are writing nothing but the stacking of the compressed frames into the sequence. So we would be getting the output video. So that I have showed you that YOLO video, right? So that video is being passed to the second module. See, you can see here that video is being sent into the second module, and the second module basically MiDaS, basically a star planning algorithm and everything. So I would be showing you the architecture of YOLO plus MiDaS and the tracking, the total first module. So you can see this, we are passing MP4 and everything, and we are using codec for encoding, decoding. So I think we are using the codec here. We will use codec here for the encoding, decoding. So raw frame, and we are using the YOLO and MiDaS. So, and also we are using tracking and combining everything. So at last we would be stacking and we would be getting the output video. So it's an entire flowchart of the first module. So I think you guys are understanding. And while going to the module two, it's semantic segmentation and gestalt algorithm. So it's an the first module output is being sent as an input. So it's basically after decoding, we would be getting a numpy of RBG, right? So the raw vectors, the raw frame is nothing but it is denoted in RBG vector. So this RBG vector, it's been converted for the SageFormer. We need to be converted it into GRB or BRG. So in other extension, we would be changing this RGB. So we will change to that particular extension. And this one is used for the segmentation, and we are using the road mask to retrieve the drivable area. And we are using a cost map for finding the drivable area and everything. And we are using the best path ASTL algorithm, and everything is been combined and stacked the compressed frame, so it would be becoming an output video. So it's then basically the output of the second module, and the second module output is been sent into the third module. It's an control perception. It's totally based on the controllers, PID controllers, and the control logic and thresholds, everything. So this one is basically easy other than these two modules. So you guys can understand if you guys see this next video, the technically understanding everything. So these are the total architectures and everything. So you can see here. So the because for the distance or the depth we are using MiDaS, and we have implemented the perception and the planning and the ground in that new modules or the new planning. So it's the total basic idea and the concepts which we are used to implement the self-driving car. It's navigation and collision avoidance. So you guys can take your input accordingly. So I would tell you guys that take an input with less noise or the high quality. So and use pre-trained models, you would be getting the good desired results. So for the technical background, I would be explaining in the next video. So see you in the next video. Thank you.